Hi, let us discuss about the Taylor series expansion. For the Taylor series expansion is a representation of a function as a series expansion of a function about a point. So in other words, if we have a function at a point and we want to estimate the function at another point, we can use the Taylor series expansion. So let's say that we have the function at point x0 and we want to estimate the function at x. So the function at x as predicted from the function of x0 can be expressed as this formulation. This one is given from the Taylor series expansion. So the function of u at x is equal with the summation of the terms from n equals 0 to n. So this term is made of a few individual terms. There is u, n. This one indicates the order of the function at x0. Multiply with x minus x0 to the power of n over n factorial. So the other terms beyond n is called the TE or the truncation error. The TE refers to the truncation error arising from the truncated values and the actual values. So let's say that the function of u at x is one specific values, and this one, if we take from a few terms, will have a different values. The differences between this and these whole terms will become the TE. So TE is just the differences between these two values. So let us expand the Taylor series for equation number 1 until the third term. So I use the color code, the red, the blue, and the purple to indicate the few individual terms that we have. So if we want to predict the function of u at x, the first term is n equals 0. So n equals 0 over here will give you the first term. u0 over here is the 0 order of the function. That is u function itself at x0. Multiply with x minus x0 to the power of 0. This whole thing will give you a 1. And 0 factorial itself will give you a 1. So what being left over here is just a function of u at x0. The second term is 1. So u1 over here is the first order derivative of function of u at x0. So this one is the first order. U prime over here indicate the first order derivative. Multiply with x minus x0 to the power of 1 and over 1 factorial. So the term for the second terms are u prime and x0 multiply with x minus x0. The third term itself is n equals 2. So n equals 2 is u prime prime, that's second order derivative of u at x0. Multiply with x minus x0 to the power of 2 over 2 factorial. The remaining terms is called the TE, truncation error. So let's say that x minus x0 equal with delta x. So we can replace the terms and simplify it to become this formulation. And what we substitute is just the x minus x0 become delta x. So here is your first term, your second term, your third term and the truncation error. So this one is just for you to reflect that the truncation errors consist of the remaining terms from the fourth term and beyond. So you can expand the Taylor series until the terms that you want, the fourth, the fifth, and beyond. And once you expand, let's say that this one become fourth term. So the TE itself will consist the fifth term and beyond. So let us try an example. So let's say that there's a function of ux at a specific point located at xi. So the distance between the point and the neighboring point xi plus 1 and xi minus 1 are the same. We call it delta x. So for us to estimate a similar function of ux at the neighboring point at xi plus 1. So the function of u at xi plus 1 is equal with the expression of the Taylor series. This one is for the first term, that's n equals 0. So u at xi plus with n equals 1, so this one becomes the first order derivative. Multiply with xi plus 1 minus xi. This one is your third term. So n equals 2. So this one becomes second order derivative. This xi plus 1 minus xi to the power of 2 over 2 factorial. The remaining terms we treat as the TE. So we can further simplify it using the xi plus 1 minus xi to become delta x. So here we simplify the terms, and xi plus 1 minus xi will become delta x. So this one is your expression for the function of u at xi plus 1. So we try another one to estimate a similar function at neighboring point xi minus 1. So xi minus 1 is here. So the function of u xi minus 1 is equal with u at xi. This one is first term, this one is your second term. Second term is n equals 1. So over here is the first order derivative of u at xi multiplied with xi minus 1 minus xi plus the third term. So this third term is n equals 2. So this one is second order derivative. This one to the power of 2 over 2 factorial and plus TE. And delta and xi minus 1 minus xi equals negative delta x. This is because xi itself is larger than xi minus 1. So it becomes negative delta x. So the expression over here, the differences is that xi minus 1 minus xi will become negative delta x instead of delta x. So this is the explanation or description about the Taylor series expansion. I hope that you can understand the content, and thank you.